Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at this one. We had question 4a done. Let's have a look at question 4b from 2018 paper 2. Let cos A equal to y over 2, where A is between 0 and 90 degrees. Write sine of 2a in terms of y. Okay, so when I see sine 2a, I'm thinking trig identities. Okay, so let's go to sine 2a, wasn't it? Sine 2a, okay. So I have the choice between this one or, of course, sine 2a, I could also use this one. Okay, so in terms of y, okay, so that's what sine 2a is equal to. If I use this one, I need to find an expression for sine a. I already have an expression for cos a, so I'm good. If I use this one, I need to find an expression for tan a, and then that's tan a all to be squared. Okay, so how do I find an expression for sine a? Well, I have a little hint here as in to draw out a triangle. Okay, so let me do that. And it's cos. So if it's cos, it has to be a right angled triangle because you can only have sine, cos, and tan on right angled triangles. Okay, so cos A. So put in an angle A, doesn't matter as long as it's not the right angle. So there's the opposite side to A. Side opposite your right angle is your hypotenuse. And of course, the other one is adjacent. Okay, so then to figure out what sides are cos, so which ratio is cos, okay, you have different rhymes, of course. You have silly old Harry caught a herring trawling off America, or of course you have oh hell, another hour of algebra. It doesn't matter which rhyme you use as long as you remember that, for example, this case, cos is adjacent over hypotenuse. Okay, so what does that mean? Well, if I have cos A being equal to y over 2, then y is my adjacent side. I'm getting that from here. And 2 is my hypotenuse. Okay, so on my triangle then, this is 2. No, my hypotenuse is 2. And y is my adjacent side. Okay, so how do I find my third side? Well, of course, you use Pythagoras' theorem, which is c squared is equal to a squared plus b squared. C squared has to be our hypotenuse, so 2 squared is equal to y squared plus opposite squared. So the square root of 2, well, let me work that out just a little bit more. Okay, so 2 squared is 4 minus y squared is equal to opposite squared. So the square root of 4 minus y squared is equal to opposite. Okay, so yep, I hope that makes a little bit of sense. So this is the square root of 4 minus y squared. So therefore, I can now say that the sine of that angle A is opposite over hypotenuse. So it's the square root of 4 minus y squared over 2. Or of course, I can say the tan of A is equal to opposite over adjacent. So it's the square root of 4 minus y squared over y. Okay, and then you fill it into whatever identity you want to use. Okay, so I'm going to try this one because it's obviously easier. So it's 2 times sine A. So that's the square root of 4 minus y squared over 2 times cos A, which was given in the question. It's y over 2. Okay, so some of those 2's can cancel as long as one is on the top and one is on the bottom. So then I end up with y square root of 4 minus y squared over 2. So that's what sine 2a is in terms of y. Okay, of course you should get the answer with the other one. So sine 2a in that one is equal to 2 times the tan of a root 4 minus y squared over y over 1 plus the square root of 4 minus y squared over y, all to be squared, okay, because tan squared of a is the same as tan of a, all to be squared, okay. Square this one, get a common denominator, turn it upside down, and you're going to get the same answer as those ones, okay? So give that a bash. If anyone has any difficulty, leave a message on the channel, and sure, I can give it a bash and see does it work out. Okay, so that was question 4B 2018. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.